right, so 6.4 is factoring polynomial. We have several subjects here. I believe it's from 1, finding greatest common factor, all the way to the 6th one, factor some different cubes. So 6 topics. Factor is important. I don't know how much math you have to take, but as long as you take in math, you need factors. Every single course is always come back to factoring. So greatest common factor, for example, let me give you an example first before I start with the theory. For example, I want to find the greatest common factor of 8, 12, and 36. Right. So what I'm going to do, I'm going to use the process called prime factorization. Like the name suggests, right? What I'm going to do is each number, 8, 12, 36, I'm going to split it into until I cannot split it anymore. Right? So I'm going to write it into a product of a bunch of primes. It's a theorem. Every number you can write it as a product of primes. Right? So instead of 8, I can write what? 2 times 4, or better yet, 2 times 2 times 2. Right? 2 is primes. Right? What about 12? Somebody try 12 for me. You can do slowly. First of all, 12 is an even number, right? When it's even number, you divide by 2. So automatically you have what? 2 times 6. Yeah. And then you keep breaking it down. What is that? Two times, well, 6 is 2 times 3, right? 2 times 2 times 3. Notice that I write things in a match column. So the 3, I don't put it under the last 2. I put it in a different place, right? The next column. I'll show you why. And then 36. Again, it's an even number. You automatically divide it by 2. So 36 divided by 2 is, you won't have it on top of your head. $18, right? And then you keep dissecting 18. So 18 is of even number again. So 18 times 2, 18 is 2 times 9. So 3 times 3. And then take a look at this. I want to know what is the common factor of each of the numbers, right? So the reason I'm writing on the matching column, because I can do this. Oops. So everybody have 2, right? And also the next column, everybody have 2. I'm going to highlight it. However, for the third 2, the 12 and 36 does not have it, so I'm not going to highlight it. And same thing with the number 3. Number 3, 12 and 36 have it, but 8 doesn't have it. So I'm not going to highlight it, right? And then here and now what we're going to do next is you're going to multiply those common factors. So everybody have a 2. So 2 times 2 is 4, right? 2 times 2 is 4. 2 times 2 is 4. So this, therefore, your final answer, GCF, is equal 4. Good. What about 7? The next one, 7a squared b, and then 14ab squared. Again, you have to write in column. Right? So 7 is already prime, nothing I can do. Right? So 7a squared is the same thing as a times a, right? And then times b. 14 is an even number. I divided by 2, so 2 times 7 times a is only 1a, but there's 2b, so b times b. Do you guys get the idea now when I write like that? And then you match up the column, right? I don't have the first one, I don't have it, but I have the 7 and I have the a. That's all I have, right? And then you multiply them together. 7 times a is 7a. It's yes. Oh yes, sorry, I didn't see. Oh, yeah, thank you very much. You pay attention. Sorry. Thank you. Yes, 7AB. It's low, but it's the easiest one, and you're less likely to make mistake. It's low. It's okay. A lot of people, I don't know why, but a lot of students have trouble with GCF. I think because they confuse with LCD, the least common denominator. Now, somebody can argue with me like Mimi. The first problem, A equals 36, the common factor it could be 2, right? Because everybody got divided by 2 to divide everybody. However, it's not what? It's not the largest common factor, right? The largest would be 4. You can have many common factors, but you want the greatest. That's why they call it GCF, greatest common factor. So here's the step. First, you factor each the coefficient into params, like we did. Right? We just write it as a product of param. Any number you give me, any number I can write it as a product of param. At all. It's actually a proved theorem, right? Of course, you don't prove it till you go to grad school, but that's the idea. And then write all variable with exponents in expanded form. This sentence is just saying that, for example, a squared, that's in the exponential form, right? You want to expand it into 8 times 8. That's all we want. And then next, you're going to list matching common factor into column. Like I did. And then bring down the common factor that all expressions share, and then multiply the factors. Why don't you try number one? You know, I'll try number 1. You try number 2. Let me try number 1. So I want to factor 3y minus 15. Let's start with the number first. Between 3 and 15, I can factor out 3, right? By the way, when I say term, I mean like 3y in my first term, 15 in my second term, right? So when I factor out 3, what's left for the first term? Just y, right? And then the second term, 15 divided by 3, negative 15 divided by 3 is negative 5, right? Then you're done. You're done. Try number 2. What you have? Yeah.
4x.
Mm-hmm.
It's x squared minus 2y minus 7.
Yeah. You guys have that too? Yeah. Okay. Right, someone else try that one. I'll give you a second. Maybe I'll walk around this one. I forgot my my shield. Usually before the mask was required, I don't have my shield, but now the mask is no longer required. I don't like masks. Trust me, when I teach, like you have to blow back to my face. It's hot. So I'm glad they kind of take that off. I know some of you maybe get nervous, like, oh my God. But when I come close to you, I'll wear my shield, okay, my face shield. So hopefully make you a bit more comfortable somewhat. Anyone? What's your name though?
Alex?
Alex, or anyone beside Alex? All right, go ahead.
I got 3.
Oh, sorry. Yeah. You have next chain, don't worry. Yeah, go ahead. 3y.
And then in the parentheses, I'll make it 3x plus 2x squared plus 7y squared.
Okay, good. Almost correct. Almost. It's not wrong. Almost. You're just missing something. It's not wrong, but maybe I want something more. Do you have a different answer? No. All right. Anyone have a different answer? It's not wrong. What he wrote is not wrong. It's just I want him to factor out the negative. Yeah. Right. So maybe I factor out the negative 3y here, and here will be positive. The next one will be negative, right? That's why I have little notes here. That's okay. That's why I have little notes here. You always factor out the negative for the highest power. When you say highest power is right, this is a bad example, but we'll continue. It's okay. But the point here is you factor out the negative. Okay, it's a bad example. Its highest power is x, is y cubed, or you can choose y x at your leading variable. Still, both cases we don't have a negative for x squared or y cubed. But the point here is you factor out the negative. Let me make a note for myself. It's good practice, but it's not. It doesn't make my point. So note. What I wrote. Always factor out GCF. First, if I give you a bunch of, I give you a polynomial, the first thing first you look for is the GCF, and that's include -1. Include -1 if the first term is negative. Hi.
I'm trying to open the classroom next door.
Oh, okay.
Can I borrow your key?
Sure, yeah.
Or if you could come over with me. Thank you.
I'll rewrite this. All right, if the first term is negative, what I said. I guess it's not a bad example. I'm gonna erase it. It is. I would like another example, but yeah, I think I'm gonna change it next semester. I'll change it. Does anyone have a question about this? So far so good. Pretty straightforward. Yeah. All right, group factoring. When do we use group factoring? We use it when we have 4 or more terms, right? Especially 4, right? Or 6, even term. So you have 4, 6, 8. You usually use group factoring, right? So the step here is first we're gonna group term with common factor. Maybe you know what I'm gonna do? I'm gonna go through a problem and then I'll talk about the step. That makes more sense. I thought I changed this. I did not. Darn it. It's supposed to be a y here. I thought I changed it. Right, that's typo still. Supposed to be xy plus 3y plus 2x. So first, group the terms with common factors. Now you can group the first, second, or first, third, right? Because they have a common factor, which is x. First, second, the common factor is y. I'm just gonna go simple always. The first 2 and last 2. So I'll group those 2. What can I factor of the first 2? What can I factor out? Y, right? Y. What's left is x plus 3. And then for the second one, I can factor out 2, right? And then again, I have x plus 3. You should have x plus 3 again. Right? If you don't, then maybe you group it in the wrong group, right? Usually you should have the same thing again. So why? Because you can factor out again, right? So basically this is one term. This is the first term, this is second term. Right? Just a little bit more complicated than just x and y and z. So for the first term, I can factor out x plus 3 again, right? X plus 3, I can factor out x plus 3. And then what's left for the first term? Well, just y, right? X plus 3 is out, so just y for the first term, and the second one is just 2. But you try number 2. You know the word, the thing here you call you try. Supposed to be a noun. It's not like you try. But I want to change it. It's misunderstanding. Because you try not supposed to be es. But this is the noun that you try. Seem you got it. You want to try it? You want to try it out? Sure.
I got x plus y.
So you group the. Tell me what you group. You group.
A out of the x plus y.
So first 2 and last 2.
Yeah.
Okay.
And
All
then
right.
the second one, the -2 out of the x plus y.
Mm-hmm. So -2 and then x plus y. Good. Very good. And then factor out x plus y. What's left is a minus 2. Can you guys log into Zoom? Can you log into Zoom? Yeah. The link is on Moodle. I'll tell you why I need you to log in there. Because a lot of time I'm gonna ask you to put your answer in the Zoom chat, and that will be your bonus check mark if you got it right. Kevin, try the third one. Try the 3x one. And you can put in the chat. So you can put the answer for you try, the last you try on in the chat privately to me. And remember your how many times you got it right. Okay, because you're the one who's responsible for putting the bonus. Every time you get it right, you got a bonus. I'll send on the link.
Same address is invalid. Yeah, that's what I said.
It's okay if you don't have it today.
Just download it.
Just remember which one you got right. Just the answer. I believe.
You said set up private, right?
Yeah. Sorry, Devin. How come I'm echoing? Oh, all right, thank you. I don't see it here though. I was checking it earlier. I didn't see you have it on it. I don't see anything here. Maybe it's in let me check. Maybe because the iPad was a hose. Yep. So my x plus y, a plus 2, y plus z. Oh, you.
I'm just doing the old one.
Oh, okay, that's okay. Yeah, like that's all right. Curtis, Kevin, good, good. Okay, Alex have the same thing. By the way, it's multiplication is computed, so 3x minus 5 come first, or y plus z come first, doesn't matter. Right? It's the same thing. So I'm gonna group the first two and the last two. It's not always the case. It's not always. But if you see a common factor, you can do like that. It's just make it simple. So for the first two, I can factor out 3x. So what's left is y plus z. And then for the last two, I can factor out -5. What's left is y plus z. Again, it has to be. If it's not, then something wrong. Because you want that same factor again. Y plus z, so you can factor it out. And what's left is 3x minus 5. Do you have any question? Okay, we're gonna start. Let's see. I think we can. Yeah, I think we start here. We can start with this one. So now it's factor trinomial with the leading coefficient. What does trinomial mean? What do I mean by trinomial? It means a polynomial has how many terms? 3, right? Three. Right? Triology, triangle. So the form, it will be x squared plus bx plus c. So what I meant by leading coefficient of 1 is the x squared term have a leading coefficient is 1. Right? So 1 times x squared. We don't write it there. But it's always the 1 there. Same thing down here. First, you have to write it in descending order. In descending order. In this case, x will be your leading variable, right? So the highest power of x, and then go down from there. And then for this class, I'm going to show you 2 methods. It's called the AC method, and then the guess and check method. Depend how well you are with the factor. If you are really good with factor, maybe you like guess and check. It's faster. But it has its down low, right? Sometimes it's kind of frustrating. You cannot find the 2 numbers. But for the AC method, for the people who not good with doing things in your head, calculating and computing things in your head, rearranging number in your head, you can always use the AC method. AC method is slow, but it's more guaranteed. Right? I used to guess and check a lot because I've been doing this for a long time, but AC method, I would recommend for someone who's not, mastering factoring. So we'll talk about that. So use AC. Let's look at my note. AC method. And yes and check. Try and error. Yes and check. Now for the AC method, the procedure is that we're gonna find the product. Usually a lot of time I just say P. The product is gonna be A times C. Well, what A is here in this expression? What's A in this trinomial? A is always, what is A? Well, C is some number, but A is always 1, right? A is always 1. So basically it's 1 times C, right? Actually, A, that little black thing I wrote there. So A times C, right? A is always 1 because leading coefficient is 1. And then times C, well, anything times 1 is just itself. So the product is going to be C, and the sum is it's going to be B. So I want you to find 2 number. That when you multiply, give you C, and then when you add, give you B. Okay, so let me demonstrate. I'll demonstrate to you. So here this mean I want you to find 2 numbers, multiply to get C, and add to get B. What I meant by that. So let's start with the example. everybody know how to FOIL, right? You guys know how to FOIL. If I give you, for example, x plus 2, x plus 2, x plus 3, and ask you to FOIL it, right? So it's in factor form. I ask you to FOIL it. You do what? First, outer, inner, last. Right? So first is x times x is x squared. And then x times 3 is 3x. And then what? 2 times x is 2x. And then 2 times 3 is 6. Right? Do I finish here? Should I do more, or am I stopping here? What should I do? Yeah, combine like term, right? So the like terms, you combine them. So x squared plus 5x. By the way, when you combine like term, adding or subtracting, you add and subtract the coefficient. Right? You leave the x alone. It doesn't mean 5x squared, right? Plus 6. I told this to my 661 student all the time. Right? For some reason, they just make it into x squared. All right. But what if I give you this thing? I give you this thing, and then I'll ask you to reverse engineer. Okay, so if I give you x squared plus 5x and plus 6, and I ask you to factor it, how do I do that? Okay, so here I'm gonna say factor using AC method. And here is guess and check method. I don't have enough space. I'm just gonna say guess and check. Right, so just like the procedure, right? I want to find the product, so the product will be what? Product is 1 times 6 is 6, right? The product is always C, so 6. And then the sum is 5. Can you give me two numbers that when you multiply give you 6, and when you add give you 5? Good, 2 and 3, right? Let me go slow. 2 and 3 it is correct choice, but let me go through slow. So first, if imagine I don't know anything about factoring or AC method. The product of 6, two number give me multiply give me 6 will be what? Either 1 or 6, right? Or -1, -6, or 2 and 3, right? Now 1 times 6 is it actually 6, but when you add them, does it give you 6? No, it gives you 7, so we don't want that, right? It gives you 7. So no. Same thing with -1, -6. The product is 6, but when you add is -7. Right? Again, we don't want that. The third choice, product is 6, and the sum is also 5. So this is your guy. The reason I'm showing this because sometimes the problem is more complicated. Sometimes you need to write things down. Okay, so now I can rewrite this. What I'm gonna do is I'm gonna split that 5x into 3x and 2x. So x squared plus 2x plus 3x plus 6. Doesn't matter, you can do 3x plus 2x. And then you have 4 terms. So what kind of factor I'm gonna use here? What strategy? 4 terms. What strategy for 4 terms? We just did it. Yeah, grouping, right? Remember grouping say what? Grouping say, maybe I'll highlight in green here. When you have 4 or more terms, right? So I'm gonna group the first 2 and the last 2. You can do the first and third and the second and fourth. I'm just gonna keep it simple. So the first 2 I can factor out x. I got x plus 2, and then the last 2 I can factor out 3. X plus 2, x plus 2, x plus 2. Can factor out again. I have x plus 3. There you go. Right, go back to the FOIL problem. So that's the AC method. It's slow, but I kind of like it because when you factor out something that is no longer a coefficient of 1, this is kind of better, right? You're less frustrated if you use the guess and check. All right, so guess and check. Again, let me rewrite the problem. X squared plus 5x plus 6. So when you factor, you know that you have to write out two binomials, right? Multiplies x plus something, x plus time, x plus something. So put this away. All right. Okay. So first of all, I need x and x much because x times x is x squared, right? Two number multiply give you 6. Add give you 5. So I'm supposed to say 2 and 3. Don't worry about the sign. Not yet. They both positive, so it has to be plus 2 and plus 3. And you're done. On the exam, you can do this. I don't mind. I don't mind. Whichever. Which one you like better? You can check or AC method. I think for factoring leading coefficient of 1, a lot will like get check. A lot of like 95% will you get check. It's faster and it's not too bad. It's not too bad. But sometimes if I give you something like, don't write this down. I'll erase it. X squared plus 5x plus, I say plus 2 or plus 3. And then people try guess and check. And sometimes it's kind of frustrating. You cannot find two number, right? With the AC method, you kind of be able to tell right away. Stop right there. Okay, so what a two number product is 3, sum is 5. I don't see many, right? 1 and 3 added all we give me 4, right? Can't go up to 5. So if you cannot factor, what do we call it? If we cannot factor, what do we call it? Start with a P. Prime, right? Prime. Remember why is prime? Because you cannot break the prime number anymore, right? That is prime. You cannot find two numbers that multiply give you a prime, right? So things you cannot factor, you cannot do write a products of factors is called prime. So erase that. All right, let's try 1 and then I'll let you go. Let's try, you guys go ahead and try number 1. You okay there, Kevin? I see you keep going in and out. We are at number 1 right now, Kevin. If you want to put your answer in the chat.
All right.
Sure, if you want to. Yeah.
the right track.
Yes, yes, yes. You're on the right track. AC method. I'll do AC method just for now. Okay, one more time, and then for the next time I'll use the guess and check. Maybe we'll see. So product is 10, sum is 7. So the only two number give me product 10, sum is 7 is 5 and 2, right? So that means I'm gonna break that 7x into 2x plus 5x, and then plus 10. Now we group. So I can factor out x on the first two, and then I have x plus 2, factor out the 5, I have x plus 2. And now you factor it again, x plus 2, x plus 2. And then x plus 5. Not bad. We done more than I wanted today, so I'm really glad. I think we're on schedule. We're good. All right, that's all I have for today. Have a good one, and I'll see you tomorrow. By the way, I let you zoom in, but I really encourage you to come. It's easier for me to teach you when you're here, right? Because when I point at things, you're not gonna see it on the Zoom, right? And I don't want to be alone. You guys, I'm just being here all by myself, talking to myself. Everybody at home zooming.